So I'm going to create a new class. I have these two subdirectories, one geometry, the other one is model. And what would be the good class name? Dog or cat? Cat, dog? Creature. Okay, so creature is a neutral name. And then class, creature, I'm going to extend from object group, right? Okay, and then the only thing I need to complete here is the constructor. Okay, and then the constructor must call the parent constructor, so I have to call super gl, and now this is where I need to start building my object. So let's start with the two legs. Okay, so let's call it leg. And what class should I use for the leg? I don't have a cylinder, but I do have the polygonal prism, right?
Just give it lots of sides.
Okay, and what are the parameters? I don't remember. So then let's take a look at the class, and I'm going to move it down so we can see both on the same screen. So the required argument will be top radius, bottom radius, and do we set the radius of the leg? We didn't. So top radius, what would be the good number? 0.1? Smaller than that? 0.05?
Gotta be bigger than a tail. Let's think about it.
Okay, and then the next property will be a bottom radius. Bottom radius, same or bigger or same? 0.6, 0.06, okay? And then other required parameter is number of sides. Number of sides, I don't know, maybe 20.
Yeah, 20. Think around.
Okay, and then height, required property here. No, the leg. We are building the leg.
No, I think it's like
1?
One.
Okay,
Build in somewhere in the body. It's fine.
okay. Okay, and then just start with this group, push, and then leg. We don't have a color yet. The color will be random at this point. Okay, but let's see if we can see a cylinder showing up. And what I'm going to do, I have to add the new class as a new script. So I'm going to add script src equal model creature JS, and I'm going to change my render. I'm going to remove my Olympic, and I'm going to create my cat dog, new creature GL, and then just put the object into my all objects, cat dog. Okay, and then let's render it just to make sure that we don't have any errors. Yeah, we see one leg. Okay, so and then but is this oriented in the right way?
Yes.
Which axis do we want it on?
So
You said the z-axis, right?
the z-axis, right? So are we going to build 4 legs? Yeah. Okay. So then I assume that the we can shift the same legs to 3 locations, correct? Okay. Where's my class? Here. Okay, so let me call it leg 0, leg. Actually, I'm going to be lazy here. I'm going to just write a loop. and missing the opening curly bracket, so then the 4 legs, oops, are in the loop. Oh, but I need to shift it a different amount, right? That's not going to work. Yeah, we can. Switch statement? Yeah, okay. Switch K, yeah, I don't think this is a good idea. Okay, so then we want to transform, okay, we want to translate. So I'm going to do mat for translate leg coordinate frame. Okay, leg coordinate frame. So what would be the amount of, so the translation will be on what ground, on what plane? It will be on the XZ plane, right? Because the y-axis is pointing to the sky, right? So the translation will be along the XZ plane, right? So we're gonna translate along the XZ plane, and I do have to create a new vector vac3 from values. How much to translate along the x? 0.2, 0.02.
Yeah.
Okay, and then nothing on the y and on the z. Did we say 0.75?
Yes.
Okay, so then we can
We have fix the x-axis because their 0.2 isn't bigger than the radius.
okay, make it smaller.
No, that's going to overlap, so it needs to be more than that because even 0.4 is less than the diameter of the object.
It's just point
overlap.
0.2. 0.2.
0.2?
Yeah.
Okay, thank you. So this is more than pair programming.
Yeah, we could keep the translate and just change the vector each time.
Right. So what will be the amount here? Minus, oops, minus, and then for the third one, it will be a positive and minus here, and then it will be 2, and then copy and paste, and the last one will be minus minus. Okay, so let's confirm it that
Change the case number.
missing
Case 3.
case 3, thank you. Okay, let's refresh. Ooh, what's wrong? Ah, because the cylinder is built around the z-axis, right? So then we need to rotate and then translate. Okay, so we need to rotate and translate. So how do I do that? Do I translate first or do I rotate first? So if you're going to be doing the rotate or the translate function, the operation will be multiplied on the right side. Okay. So be careful with the sequence here. So I think I want to I think it will be easier if I can apply the operation with respect to the world. Okay, so if I want to apply the operation with respect to the world, then I want to multiply on the left side. Okay, so then that means I have to use multiply. Are you with me? Because once you rotate, then everything is rotated, right? So the translation is not going to be along the XZ plane anymore. It will be on a different plane. It will be on the XY plane. So you have two choices. So which one are you going to do? Are you with me?
Yeah.
So after you rotate, right? After you rotate, so the Z is now on the Y-axis. So RGB. So the cylinder is built around the Z-axis. So once you rotate the cylinder, okay, so now when you apply translation, you have to be careful because do you want to do the translation with respect to the world or with respect to the rotated coordinate frame? So it's your choice. Which one? The world? Okay, if you want to do the rotation with respect to the world, then you need to do the multiplication on the left side. That means you have to do multiply. Okay? Or the other choice is you can do the translation with respect to the rotated matrix, to the rotated coordinate frame, but now the translation will be with respect to the XY plane. Confused?
Would it possibly just rotate the Z-axis to point through the animal?
What is your question again?
Just take it so that way the Z-axis is just pointing up through the animal instead of with the animal.
Yeah, we can.
Translation
We can.
is a
It's
lot
up to you.
easier, so then we just translate it.
Yeah. So you want to change the axis assignment?
Because if we have to rotate right now, we're going to have to rotate everything and translate everything as we build it, which is going to be a lot more rotating and translating down the line.
Yeah, but when we build the neck and we build the tail, we have to rotate anyway.
Right.
When we build the body, we have to rotate. So yeah. So it's up to you. So you want to change it to Z? Okay. If you want to change it to Z, that's fine with me. That's fine with me. Okay. So then, which axis is the forward? Y? Okay. Okay, let's do that. If you want to do that, then that's fine with me. So now that means the translation will be done with respect to the XY plane, right? Okay? Okay. So then it is a matter of changing the translation to XY instead of XZ. So XY and then XY, oops. There we go. And then you can refresh, go back to the page, refresh, yes. So now we have the 4 legs up, okay? And then the next step is to build maybe the body, okay, the torso. So the torso will be built on the Z-axis again, okay? And then you need to do a couple of options here. You need to translate. Okay, so we can because at the end, so once we have the torso will be built around the Z-axis, we have to bring it. Well, remember the base of the cylinder is at the origin, right? So when you move it up, when you translate there, then be careful because when you rotate, the effect will be like this. So when you rotate first, the effect that you will see, let's say you rotate around the x-axis, then the body will be too much to the front of the dog. So then you need to translate by that much, and then translate again. So we need to do 3 separate operations.
Why do the two translates need to be separate? translate X and Z, or Y and Z at the same time? If you rotate it now, then can you translate X and
Yes,
Y and Y?
yes, yeah, you can. Yeah, you can. You're right. Okay. So, but now, are you going to do the so for sure the translation is the kind of the easy part, right? But then when you do the translation, I mean the rotation is the easy part. Now, when you apply the translation, are you going to do the translation with respect to the original coordinate frame or to the rotated coordinate frame? Again, you need to be careful with the values that you pass to your translation amount. Are you with me? Okay. Because now, let's see if I can mix up the. So after you rotate, okay. Now after you rotate, then if you want to do the rotation with respect to the rotated axis, then the translation should be done on the YZ plane. Okay, not the YZ, but the amount is like the up is not Z anymore. The up amount is the Y amount now. You see that? Okay, so let's do that. Okay, let's do that. So let's rotate and then translate. But now remember that the up is now the Y, and the right is the blue one, the Z. Okay. Yes, Phil?
All the coordinate frames for the objects don't have to match, so when we apply a translation to the whole family, like the head doesn't move one way and the body moves another,
As long as you agree with that initial coordinate assignment,
then you're fine.
whenever you apply transformation to the entire dog, everything will be done with respect to that coordinate frame. Yeah. Okay. When you build each object, each individual component, you may be using different coordinate frames everywhere. Okay. But once you build as a group, then when you transform the object as a group, the transformation will be determined by how you assign that coordinate frame. Because that's why it is important how you assign that coordinate frame. Okay? So now let's build the torso. And I'm going to build the torso. This is outside of the loop. So let torso new polygonal prism GL, and the required argon will be top radius. What is our top radius? 0.5, 0.3? 0.3, okay, and then the bottom radius is the same.
Length was 2.
And then the length or the height, 2, and what is the required parameter? Number of sides?
4.
4. Okay, let's make it 6. Okay, so I think that's good enough. Okay, so you have the torso built, and then you need to apply the transformation, right? So then the first thing that I'm going to do is I'm going to do math rotate. Rotate around which axis? X. So I'm going to update torso coordinate frame. Torso coordinate frame. And then the amount is GL matrix, 2 radians, 90 degrees. Okay, and then after that, I'm going to translate torso coordinate frame. Oops. torso coordinate frame, and then what is the amount? The amount will be vec3 from values, and this will be along the YZ plane. Okay, along the YZ plane. So no transition in the X direction. And what will be the amount?
One and then the height of the legs.
So half of the height, right?
Yeah.
So 1 along the Y, okay? Minus 1 along Y. Minus 1 along Y, and then 1 along Z? Okay. Okay, let's see. And then I need to add my, oops, sorry, thank you. Coordinate frame. And then let's push that torso. And let's see if we can see the body, the torso. Oh, wrong direction. Okay, it has to be like, I think we mix up the minus and the plus. So it has to be positive Y. It has to be a positive Y amount. Right? So positive Y amount and then positive Z amount. Y, positive Z. Okay, let's fix that. Positive Y, positive Z. It's closer, but not.
Negative Z.
Negative Z, positive Y.
No, we need to push more.
The Z was
Yeah,
rotated.
because the,
If
but
the
the
Z
Z
is
is
rotated
rotated over,
down,
so
it's gotta go back.
So the Y isn't correct, right? The Y has to be.
well,
The
we
Y is
rotated
right,
accordingly.
so the Z was rotated.
It's rotated.
Oh, you're right. Okay. Negative Z. There we go. Okay, so this is kind of the step, and you keep adding. Okay, so I'm going to continue with this example on Tuesday. So take a look at the assignment page. So I'll see you Tuesday. So what I have to add now is just a tail, and the tail is basically a cone. New cone. And what are the required parameter? The required parameter will be the radius. What will be the radius? 0.01, 0.2, height, what, 0.4, short one, okay? And then we have to move the tail to the end, right? So we need to, because the tail will be pointing to the positive z-axis, but then we need to move the tail to be pointing along the, which axis? The y-axis, right? Follow the same rotation? Yep, okay. So we can apply rotation along the x-axis. Mat for rotate x. And this one will be a tail coordinate frame. And then a tail coordinate frame. And then the amount of translation will be 2 radians, 90 degrees. Okay, and then we want to translate after that. So mat for translate. Tail coordinate frame. Tail coordinate frame. What will be the amount of translation? Vec3 from values. Wait, do we want to do we want to rotate by a positive number or negative number?
Oh, that should be negative.
Negative number, right? We want to touch. We want to because the tip of the cone should be pointing that way. Okay, so we want to rotate by a negative number. Okay, and then the translation now would be after you translate, after you rotate. Let me bring this up. So initially the z-axis, I think we changed the coordinate assignment. Now the vertical axis is our z-axis, and then the y-axis is the direction of forward for our creature. Is that what we did last time? Right? So then when we rotate, after we rotate, then so we want to rotate by a positive y value and positive z value to bring that here. Okay? So some positive y and positive z value. So x is 0. Oops, wrong. X is 0, some positive y value. The y value, I think, is 1. Yeah, and then maybe the x value, the z value is also 1. Okay, let's see this. And then add, push the tail to the rest of the group. And let's see the update. Is the tail there?
Do we have it rotated inside its body?
Yeah,
Oh,
the tail is there.
It's sticking out.
Very thin. We made to make, well, I think the diameter too small. Okay, so we want to change the diameter, the radius, to a bigger number. Okay, so 0.01 is 2.1. That's a huge one. 0.05 maybe. Okay, let's try. Okay, let's see the tail. Yep, it's there. Okay, so now we can apply shear transform. So how do we apply shear transform? So now I can create a new matrix. I call it shear, maybe tail shear. Okay, I start with a identity matrix, mat4.create. So this will create an identity matrix. So what is identity matrix? Identity matrix is matrix whose diagonals is all 1, right? Because that's what we need. So we need to start with identity matrix. All the diagonals is 1, and then we set cell number 9 with the tangent of the angle. So, and then I will update cell number 9 with math tangent and the angle of the shear amount. And I'm going to be using GL matrix to radians. So how many degrees? 40, 45? Okay, so now I have the shear matrix. Once I have the shear matrix, then I can multiply my shear matrix by using mat4 multiply tail coordinate frame, tail coordinate frame, shear matrix, tail shear. Okay, so let's check if we see the tail pointing down now. So the tail should be pointing down. If you do it correctly, nope, you're pointing to the wrong direction. So the tail is pointing up. So the angle, I just need to put the angle at a different sign. So minus. Okay, instead of plus, I want to start put a negative angle, and let's reload. If I reload, then you should see the tail pointing down now. There we go. Okay. So, question about shear transform.
So
Yes, Troy.
it's to shear. Basically, you do the transformation in the plane where you want to see it.
Yes.
adjusted.
Yeah. So in my example, I'm trying to shear along the z-axis, right? So when I want to shear along the z-axis, that's why the formula is to add some amount to the y, because the shear is along the y-axis. Okay.
So again, just to say it, this is a shear along the y-axis.
Yes. Yeah. Shear along the y-axis, but the shear amount will depend on the z coordinate of that point. As you go higher along the z, the shear amount will be bigger. Yeah. Yes.
So we could make this tail wag by just adjusting that angle.
Yes.
So
Yes.
if we had it in our anim loop, just continually adjust the angle.
Yeah.
Okay.
Yeah. So if you want to make like a wagging animation, well, are you going to make it up and down or sideways?
Just side to side. So that would be in the XZ plane.
Yeah. In our case, side to side will be along the x-axis, right?
Yeah.
Yeah. Yeah. Probably you need to do two shear amount, one along the z and one along the y.
One for the y.
Yeah.
One along the Z.
I mean, along the y and along the x-axis. You can combine. So basically, you can add x plus something here, right? Yeah. Yeah. Okay. So now let's work on the head and the two ears and the two eyes. And as I mentioned before, I think it will be easier to start everything as a group, and then we can move everything as a group up there. Or maybe we can start with the neck. So the neck is basically the same, right? Neck, new cone, GL, and then radius. Maybe the radius is bigger. 0.1 maybe. And then height. What would be the height?
0.2.
0.2. Okay. And we do need to rotate the neck coordinate frame, and then the rotation amount will be a negative number this time because we want to have the tip of the cone pointing to the positive y-axis.
The second coordinate frame is spelled wrong.
Oops, neck. Thank you. And then we do want to translate again. So how much do we have to translate?
We want to go negative though, right? The tail.
So we want to
Negative there.
negative z, right?
Yeah, negative Z and negative Y.
Negative z and negative y?
Because you're rotating the other direction, so you only want one of them to be negative now.
Yeah.
It needs to be the same translation as the torso, so yeah.
Oh no, we're still.
Okay. So and then let's add the neck to the group. Okay, and then refresh. Ooh. What's wrong?
We did count.
Oh.
We did count.
We want to do neck, not tail. There we go. Okay. Did I make a typo anywhere else? Maybe not.
I think we might be overlapping.
Yeah, I think the translation is incorrect. So I think it's hidden inside the torso. So let's comment out the torso. So I just comment out the push to of torso so we can see without torso. Yeah, so no, the neck doesn't show up. Oh yes,
Oh, he's way down.
yes.
There it is.
Wrong
Oh, yeah,
translation.
it gives you one.
Wrong translation amount. Okay.
See.
So what should be the correct translation amount?
Positive,
So-
negative y.
Let me bring up my AutoCAD diagram here. So when we built the cone is here, right? Okay. And then we rotate by, is it 90 or plus or minus? So X, red, green, blue, X, Y, Z. So we have to make sure that the coordinate assignments are right-handed. So when I turn from X to Y, I will get red, green, blue. Yes, red, green, blue, X, Y, Z. If I turn from red to green, I will get blue. Red to green, I will get blue. Right? So the initial coordinate assignment is like this. Right? So Z is pointing up and Y positive is pointing forward. And when I build my next, it starts here and I want to rotate by that much. And then that rotation is negative rotation because I'm rotating around the x-axis, but the rotation is from Z to Y. Okay? So the rotation has to be negative. Okay? They do negative, and then after you do the rotation negative, then I want to translate to this point, but this point will require me to translate along positive Z because the coordinate frame has been translated, and negative Y. So it has to be positive Z and negative Y. Okay, negative rotation, positive Z, negative Y. Positive Z, negative Y. Okay, so the rotation is negative, positive Z, negative Y, positive Z, negative Y. We flip the two signs. Okay, let's go back, refresh. Yep, the tail is in the right place, and I can put back the torso now. And then if I go back, enable the torso, and I can apply the same shear transform again. I can just copy those three lines here, but I'm going to call it neck shear, and then neck shear. Okay, and then we do want to do the other angle, right?
Don't forget to get the multiply line.
How much?
I think you want to go this negative as well because you rotated the opposite direction, so it's 45 shear up
Yeah.
is the same as the
Yep.
45 shear.
Okay, and then neck, coordinate frame, neck, coordinate frame, and then the multiplication would be neck shear. Okay, let's see if the neck, yes, the neck is pointed up. Okay, so we have the neck, now we can build the head, the two ears and stuff. Okay, so questions so far? So build the head, ears, and eyes as a new group. Okay, so we have to build a new head group, and then So what be the geometry of the head and ears?
Sphere. Two cones.
So the ear, we can start with a sphere, right? And then put the two cones, and so we can put the cone at the top, and then we do like rotate by some amount. Okay. So what would be the radius of the sphere? Probably 0.2. I think this is like 0.3. I think this is about 0.2. Okay. So I can build a head and the two ears. So let head is a new sphere. And for my sphere, I do have to say the radius. Radius is 0.2, and then split depth. The recursion depth, let's just use 4 for now. Okay, and then I'm going to add. Okay, I'm going to add the head group to this group. Okay, but then I have to add head to head group, right? Because we have 2 levels now. Are you with me? Okay. So then I need to say head group dot push head. Oops. Okay, let's see if we can if the head is the head is at the origin because we don't translate anything. Okay, and then we're gonna translate everything as a group later on. Okay, but now just work on the head at the 2 ears. Okay. So left ear, new cone, GL, radius. What would be the radius of my 0.05, and then the height 0.1. That's a big ear. Okay, so what is the trick here? So when we built the ear will be at the origin, right? And then we have to, I don't have a sphere with me. Okay, let's say this is a sphere. Okay, so when we build the ear as a cone, so this is like the origin is here, the center of my sphere. Okay, so the cone is a mini cone inside the sphere. So what I have to do is I need to translate to move it up, right? So then the base of the cone is touching the sphere, and then rotate by some amount. Okay, but which order you want to apply the 2 transformation? Because you have to translate and rotate.
Should we translate first, and then we can rotate around the radius, around the origin of the sphere?
No, because to the origin, it's going to be at the bottom of the sphere most of the time, and at the center of the story.
Is it?
So if you rotate second, you're going to end up rotating center. Or is
No, the origin's in the center of the sphere.
Oh, well, never mind.
So you have the choices. Okay, you have the choices. If you translate first, okay, then the rotation has to be done with respect to the world coordinate. Okay, with respect to the world coordinate. If you translate first, the rotation has to be done with respect to the world coordinate. The second option is to rotate first, and then you just simply translate along the z of the rotated axis. I think that one is easier. Okay, rotate first by some amount, and then translate along the new coordinate frame. Okay? So rotate first and then translate. So I'm going to apply rotation first, and the rotation will be rotation along X. Okay, and then left ear, coordinate frame, left ear, coordinate frame, and the amount of translation will be geometrics to radians, 30 degrees maybe.
Where's
Okay.
the, color buffer? So
Oops, thank you. Coordinate frame. And then I'm going to apply translation. Translate, left ear, coordinate frame, left ear, coordinate frame. Keep auto-completing the color buffer. And then the amount will be vec3 from values 0, 0 along the Z. I'm going to translate by 0.19.
Oh.
Okay. Why? Because the cone base is flat, and then I don't want to see like some gap. Okay. So let's do that trick. Okay. And then I'm going to add. I have to add the left ear to my head group, right? Head group, push left ear. Okay. So then let's see. Do we see a tiny ear? Yes, it's there. Yeah, we have the tiny ear. Okay, so I think now you know how to complete the rest. I'm not going to complete the rest of the code. You know how to work with translation, transformation, and stuff. Shear transform, basically the technique is almost the same. Okay, but now after you have the head group done, then we have to translate everything. So then the head will be up here. Okay, let's do that. Okay, let's do that. So the head will be up here, right? So the head will be like here. Okay. So, but then we have to do the rotation first because the two ears are along the y-axis. Okay, the two ears are along the y-axis. Okay, or if you don't want to rotate, then you can build the ear to along the x-axis. Okay, and then you can just simply rotate. Translate the head up there. It's your choice. Okay. So let's say I'm going to stick with this design. So then the first thing I need to do is I need to rotate along Z because now the two ears will be facing sideways. And after I rotate along the Z-axis, and then my translation will be along what axis to bring the head up here. So initially the head is with the two ears like this, right? And then I need to translate. Okay? And after I rotate along the Z-axis. And after I rotate along the Z-axis, I need to translate along what axis? Along
The whole head group?
the whole head group.
X and Z.
X and Z, right? And X and Z. Okay, so is the rotation amount positive or negative? So translate along the Z-axis. Is that positive amount or negative amount? Positive amount. Okay. So translate, rotate by 90 degrees positive, and then translate by positive X, positive Z to bring the head group to the end of the neck. Okay. So let's do that. So assuming that the ears are completed and the eyes are completed, then what I have to do next is to rotate. The rotation will be along the z-axis, head group, coordinate frame, and then head group, coordinate frame, and I do want to translate by geometrics to radians by a positive 90 degrees. After that, I do want to translate head group, coordinate frame, head group, coordinate frame by some amount, vec3 from values along x and z. Probably the z-axis is 1 point something.
1.05.
I don't know. The neck is what? The neck height is 0.2.
If you translate like just one, the head is going to be in the dead center.
Yeah.
The dead center of the head is going to be at the edge of the cylinder.
Yep.
So it needs to be at least 1.2 plus.
1.25. Okay, and then the x translation should be bigger than 1, right? Maybe 1.2.
That'll put the edge of the sphere on the edge of the cylinder.
1.1.
That'll put it
1.115.
inside.
Okay, let's try that. Okay, let's try that and see what happened. Yeah, it's there. Is it too close to the neck, to the torso? Yeah. We need to move it further away, right? So the x translation has to be a bigger number. So the x translation is
Sure. And maybe 1.15 for the Z.
1.25. Okay. Let's see. Is that better? Yeah, I think so. Well, you got the idea. Okay?